Give me a brief interview?
Yeah, sure, let's do it.
Great. So hi, we're speaking to Danny. He's got something extremely fabulous. In fact, I tried to get you on the show. We didn't connect, however, we connected here at Stanford. So, what have you done? What is this thing?
Yeah, so I'm Danny. I'm one of the founders of BioBot. We build this device over here, and basically it's a 3D bioprinter that creates 3D living tissues. And we just put the devices, we actually build the software that goes with it, and some of the inks that go into it. And the key here is that, I mean, with this technology, it's an additional challenge built on top of traditional 3D printing. And that challenge is they need to be able to cure materials or turn them from a liquid into a solid without killing the cells. And that's the innovation. We developed a new process that allows us to do that. The applications really are, I mean, people always like to think of a future where we can really have patients come in with organ failures and develop new replacements for them. But the reality is that we're far from that goal, and these devices are enabling us to begin getting closer and closer to that. So a lot of our early clients are really academic researchers at some of the leading tissue engineering and genetic medicine institutions around the world. And the applications that we're really most excited about now are using the devices to print miniature organs built out of human cells, or developing new drugs and really testing, instead of using animals or places where we simply don't have good animal models, using this technology to build models out of human cells and using those models to test drugs and really reduce the cost of bringing new drugs to market.
Very cool. As mentioned, I had an opportunity to get a sneak peek at this on Thursday. And so this is the unit there. I'm going to point the camera down to it. Can you kind of give us some details of it?
Yes, to walk you guys through how the device works. I mean, the device itself is really, the key thing that we did is we took something like these devices, used to basically fill up entire rooms, and we shrunk them down into something that fits on your desktop. And it looks similar to most traditional 3D printers. It has a 3-axis system, so this guy moves it X, Y, and this bed moves up and down. There's a syringe in here, so it's on caps. There's actually a syringe in here. So this syringe is what has your solution of biocompatible materials and cells. And the extrusion of the material is controlled by compressed air. So compressed air source and feed into this plug over here, which you would then regulate with this regulator. And that's how you control the extrusion of material. So different materials, different tissue types would have different pressures that you need to extrude at. And that's basically how the device works. The key thing is that the process that we use uses visible light to cure the materials, and that's what we're able to do without killing all of the cells. And so there's a set of LED lights housed in here that shine on the material. As soon as it extrudes out of the syringe, out of the needle, the lights shine on it and the material cures. Make this from going from a liquid to a solid without killing all of the cells.
Now that seems to be the special thing about it, is we figured out that by using a safer light source, a light spectrum, you can actually have more tangible cells or more growth, right?
Right, so I mean, it's traditional technology or like existing methods use things like UV radiation, which mutate or kill cells altogether. So by using visible light, which is less harmful, we're able to get some more, basically less mutation in our constructs. And as you build, as you're building larger structures, that becomes really important. And also, the other key thing about it is that the chemistry is modular, meaning that it works across a variety of different tissue types. So not just cartilage or not just liver tissue, but also heart, lung, bone, even the brain. I mean, the devices are being used across a wide variety of different tissue types right now. It's great to see, great to be able to see the field and technology that's accessible and sort of create a sandbox for people to begin developing it and really push the technology forward and push the application forward, which is really the exciting part here.
Yeah, that's really cool. So one other item, you mentioned some prices in the presentation the other night. You want to go ahead and reflect those again?
Sure, yeah. So really the current model we've been working with this device under is a partnership model with researchers. Like I said, mostly academic researchers right now, and for that, basically we like to tap, the goal for us is to begin getting feedback on the device. So this is our first product, and we're trying to figure out what works on the device, where will limitations live, where we have to improve on. And so by selling at a low cost right now, starting at $5,000, we're able to really get feedback from researchers in terms of really pushing the envelope of what's possible with the technology, where the field is, and research support. So not only does it create a library of information for us to know, like, hey, like, this is the landscape of tissue engineering, these are the applications that are closest to maturity, so those are the ones that we can focus on. But it also just gets us feedback on the hardware, on the, like, where exactly, like, you know, where can we expect this to be in the next 5 years? Where can we expect to be in the next 10 years? And how can we accelerate that? And that's really the focus here for us, for this first product.
Wow, excellent. And if I remember correctly, you have a little kit of collagen. And
so we actually just released, last week we just released our first cartilage kit. It's just like part of the feedback that we've been getting is that, you know, the material science part of this is hard, it's really hard. And unless you're a material scientist, as of basically up until last week, you wouldn't be able to use this technology because you need to formulate your own materials and figure out which concentrations and which chemicals, and, you know, it's just a lot of stuff to figure out. And unless you have the materials science background, it's just not practical. So our approach to this is to say, okay, we're gonna put all the material science background that we have to work. We're gonna develop standard kits for different tissue types that users just need to mix their own cells into. So these materials, or these kits that we're envisioning, are really just 5 different biomaterials mixing together with our initiator that works with the visible light, and sort of creating the standard bioids for different tissue types, where users just need to mix their own cells. You just need to add their own cells in, and that's how you keep the flexibility of saying, like, you know, there's not just one liver that we can build. Like, everybody has their own liver cells, which are genetically different, epigenetically different, and they just behave very differently. So we need to be able to keep that diversity while standardizing some parts of it to actually make it so that people can innovate in this space. And so last week we released the first of those of that line, which is our cartilage kit. It's we're just getting started beta testing it, so we've got some good data behind it, and we're excited to work with researchers who are in the cartilage space to really prove it out for us, prove it out with us, and show that, hey, this is a good alternative for people who don't really have the material science background. And it's something where, with just a device and these kits and your own cells, you can begin to prototype cartilage tissues and begin to actually make some innovations in the space.
Obviously, it's very exciting. As mentioned, I wanted to get you on earlier. Yeah. Maybe we'll do a more formal, or have you as a guest president to talk about the progress there. So thank you, Danny.
Cool, yeah, thanks so much. So this is, I think it's Stanford MedX Makers. She's the expert on the medical side. So I'm an example of a MedX maker that they brought out to started working out of Philadelphia. We build these devices, they're 3D bioprinters. And we come from a very maker, sort of like a technology evolved out of the maker movement. And they, Stanford MedX knows how to sort of like see the 3D barriers like some of the ideas and teams. We actually, we build the devices, but our clients use them to print 3D living tissues. They're mostly researchers who are trying to figure out how to build complex organs and implantation, but it's still very early in the research side. And tools like this are what's enabling them to begin exploring.
You're using it from Stanford?
We are, yeah.
So cool. It's going to do good things.
I hope so, yeah.
Oh yeah, no, this is just... I'll come back later, Monica. We'd like to do a little interview with you.
I see you.
We did an interview with John Stoll about 6 months ago and got them to 3D, so I'd like to know what you're doing here. Would you like to do that for me? So hi, I'm Mike Bolivar from All Things 3D, and who are you?
Hi, my name's Allison Berman, and I'm representing the Tech Museum of San Jose. We're collaborating with Enable to use the 3D printers that we have in our fabrication lab so that we can print as our demonstration pieces and make it something useful. So we're printing these hands. We've hooked up with a local matchmaker who sends us files customized for a local kit, and then we send them out.
Very, very cool. So how many have you done so far?
Just 3 so far.
I know that's the sad thing about 3D printing right now, but hopefully that will improve. I actually have an Ultimaker too. I'm the guy next door who printed his wife's skull. So, my wife's skull.
Oh, wow.
There's a story behind that. Make magazine did an interview about 3 months ago, and I'm actually going to be on there live with them. But I am a big fan. I was actually, John Shea was in my audience at South by Southwest. I was a moderator for the camera. So it was an honor to finally meet him. So this is kind of neat. So essentially we're going to be able to come by and pick these up today.
So they can pick them up. We have matchmakers who help get them to where they need to be. We also have like there's been remote build-a-thons. There's been remote build-a-thons also. So in areas where we don't have a local matchmaker or a convenient person to deliver, we'll send out a bunch of parts, get a community of people to build them as a group. So it's a wonderful bonding experience as well. And the community is always growing. We're always looking for more volunteers to join the enabled community. And even if you don't have a printer, you can always volunteer to help design and modify a design. There's always innovations happening in that space. Better binders, better elastic.
Wow. Yeah, it's really, really exciting. We're making some little ones over there. That's kind of neat. I see the little tiny hands over there on that printer there. So what variety do you have here? Are they just custom or they're all the same?
It started out with one hand. It started out with
the enabled, the family enabled brand. Yeah. I worked with
from
Lucas
there,
and his dad.
other people got involved. People actually got someone they were making for, and they started making variants. So there's a kid who, he and his dad have been working on one called the Talent Hand.
Yes, I'm familiar with it.
Yeah, and so we've got ones where they're meant to go to fit over a riveted piece of leather bracer. There's ones like the one we're printing right now, the thermoformable one. So someone who has differently shaped palm, it really helps provide like a custom fit socket. So all you have to do is thermoform it, and you can print it flat, which makes it faster and easier to print too.
Very cool. Now there's a reason you have Ultimaker printers, right?
I believe Ultimaker
I guess one of the best
They have loaned out to us. Ultimaker is a partner with Enable, so they've loaned these out to us, but they've also worked with us on this project. They're very good friends.
That was a loaded question. I'm also friends with Eric, the CEO of Ultimaker, so I was aware that he came on my show about it. But no, it's very cool what Ultimaker is doing. It's really cool that you guys are involved with. There's a 3D scientist that's called Yes now. I used to work with him. One of these designed for Talent. It's his design. Adrian, it was Eastern, or something, I can't remember. This is cool. This is pretty neat stuff.
Let's talk about Luke's dad. He had some different ideas.
Oh, I do a lot of feedback, so I'm probably toning myself down. So what I said is that I've met another gentleman, a scientist, 3D print scientist, a lot of who worked with John Shaw to create the Talent. So he was on camera at South by Southwest. Really great.
Southwest too.
Were you?
Yeah.
Do you remember me then?
I do remember you.
I'm the moderator of that.
Yeah, well, I'm behind the scenes. I let John and Andreas be a part.
Oh, okay. So you in the audience then?
Yeah, I was in there.
I thought you were up front, weren't you? Yeah. It's funny is that you're just worried about so many other things. Well, it's really great what you guys are doing. It was really a surprise to have John in the audience. So thank you very much.
You're very welcome.
Pretty cool stuff over there. Yeah.
He's a leader, and he speaks very well.
Okay.
All open source. Hi.
Hi, how are you? I'm Mike Balzer from All Things 3D. And it looks like you got some really neat stuff there.
So should I? You want me to just explain everything?
Okay.
You want me to just explain everything?
Yeah, go ahead.
So, should I start?
Yeah, actually, and by the way, we are live right now.
Oh, sorry. Okay.
No, that's okay.
So, we are from Galileo University in Guatemala.
Oh, okay.
And Guatemala has a history of there was a civil war, so it lasted like 36 years. So there's a lot of people that still like have amputees or don't have limbs. So we thought, okay, maybe we can solve that problem. So we designed this hand. This is a 3D printed hand. This is actually the hand that is used by an ex-soldier in Guatemala. A grenade like took his hand. So how this works is this puts this on. This is very low cost. Like this is under $15. A normal prosthetic like the hook device in Guatemala costs like $2,500. So this is much cheaper, and it looks like a hand.
Yeah.
So how this works is you just put it like this, and then when you do like this, you feel like you're gonna break your shirt. So if he does that, for example, on this position, he can carry a bag. So like this, and he can carry a bag. So this kind of position is for carrying objects in the toolbox. He's been using this device for approximately 8 months, and now I can do this thumb rotation mechanism. So here I just press this, do the thumb rotation, and now I can grab like smaller objects.
Oh,
So for
wow.
example, if I wanted to grab this little bar, I would just put it like this. There, I grabbed it, right?
Wow.
And let go. So this is very low cost, and it works. But then we had another patient. So this patient, he just puts a glove on and nobody notices he doesn't have a hand. And he can write, he can bring coffee, he can do a lot of things. But then we said, okay, we had another patient. And this other patient, he wanted a bionic version. So we started designing the bionic version. So this is the bionic version. So this one, it's a hybrid. So if he doesn't want to use the bionics, we'll just put it and activate it just like the other one. So when he does like this, like the hand closes, but the thing is, you don't have per finger movement. So if you want per finger movement, then this is the one to use. This is still low cost, this is under $500. A normal bionic one is like $45,000.
Yes,
Much cheaper. Everything is open source, do it yourself. We designed some of the electronics for it.
Okay.
For example, this is the chip that the circuit that we designed that reads the muscle data. So, and you can download this at Oshpark and then just build it yourself.
Okay. So if somebody wanted to find out more information, what's your website?
Yeah, Turing.galileo.edu. We can give you that, but Turing as the scientist Turing, and Galileo as another science. So Turing.galileo.edu. This is the hook that he used to have.
And just the microphone.
And he hated this hook. Like he was always, his hand was always in his pocket. So we just took out this and we used the same screw. And now like this is the hand that he gave me. So this has all the motors inside, and this is my muscle cord. For example,
You're just a proper result. I mean, you need.
there, when I do like spring, it reads the muscle data and it transmits it to a computer. And this computer has like various modes of operation. So there, I'm just close. I can select, for example, I can select the point. So now when I close, it's gonna do the point.
Oh.
You can do, for example, like this.
Now that looks like it's made to put around your bicep, your around your wrist, or that way they can access the panel there.
Oh yeah. The panel can go like on the other hand, so he can select, or it can be like a watch, so he can select things there. And I can go to my Europe. So now it has various languages. I can speak in Spanish, English, Japanese. I'm gonna do the demo in English. So I can tell him one. Yeah, there's a lot of noise right now. One. So now it does the one. Where I can tell him, like, I can give him voice commands and he will understand them.
Oh, very neat. So then it will provide a...
For example, like a mouse click. I can tell him mouse click, and then when I do like this, it activates the action.
Oh, very neat.
It also has an AI mode in which I can configure it like the patients, they don't have a hand, but they still remember how it felt to point or to do number 3 or whatever. So they just start training the AI.
Yep.
And once they train, for example, if I do like this is configured for one action. So this is one action. This is pink. So I just like, I'm doing like this. If I, like, I'm normal again, and then this executes another action. So we just configure it to different actions. Yeah, and also this is a per user. Like, every user has to train it by themselves. So the patient starts training the machine, and the machine like they both learn from each other. And actually this started for us like an engineering problem. So we were like all focused on how to fix this and that. But the first time that we used it on the user, on the patient, that was like a very important moment for us, because we kind of like saw it how it actually changed the world, the life of that person. This, for example, the guy had a motorcycle problem, accident, and that's why they had to cut his hand off. And he was having some problems that he said that the nails were hurting him.
Yeah, phantom limb syndrome.
So with the hook, he couldn't like open it. And when we put this on, and he managed to open it, then we were like, wow, the pain went away. So the visual cue of opening his hand helped him with the pain.
I don't know if you're familiar with the study by Ikebani, or the mirrors.
Yeah.
So it seems like this would be the next step, where you could actually control it, and then you would rewire the neurons in order to see it. Excellent.
Yes.
So have you talked to Ikebani? Ikebani?
No.
He's the lead researcher in phantom limb syndrome. Talk to him.
Okay.
If he's not already doing it himself. But this obviously is a low-cost solution.
Yes.
It's IACCOBOLI.
Okay.
Well, I'll give you my card. Get with me. I've talked to him in the past. He would be very interested in this.
Thank you. Yeah, because it's like the first time that when we saw his face, like our patient's face, and that he had a hand again, he was all excited. And actually, if you see this hand, it doesn't look human. It's a cyborg hand. So now, like his Facebook profile is a T100 from Terminator. So like he's proud of wearing it.
Yeah, well, that's what the kids from Enable, they're proud of it.
Yeah.
So that's what's happening. In fact, if I lost a limb, I'd be proud of it. But it's funny, I do 3D scanning and thought, well, we can scan the other hand or arm and then just model that to create a life. But people don't want that. They like the cyborg.
Yeah. So like the other patient did want like the natural look, but this other guy, he was like, no, I'm proud of it. And when he uses the hook, he hates it. But when we gave him the bionic version, he's like, I want to show this off, and he's okay with it. So we think that that's also important. And all of this open source, it's online. You can just download the files, build it yourself.
Required one hand is okay.
Huh?
Required one hand should be okay.
Yeah. Right now it's just for people that have lost one hand.
Very important.
And also, like, we're adding other stuff. For example, we're thinking, okay, how is he gonna use his remote controller? And we thought we don't need to like add that functionality. We can just insert an infrared like transmitter, and then he can just like go into TV mode and just switch channels or volume just like that. Or you can connect him to the internet or whatever. Like. So he doesn't need to, like, for typing, he doesn't need to actually type. He can just like type with like Morse code or something like that.
That's like the people who are doing the studies with eyes, just by eye movement.
Exactly.
In fact, what's the name of the scientist? I can't think of him now. The one that the cerebral palsy was completely lost. He's naming statesman, but he's a famous scientist, mathematician, astronomist. But that doesn't matter. They made a movie about it. But he used a similar type of system as well.
Yeah. So, I mean, we think that there's a lot of possibilities.
Stephen Hawking.
Okay. Yeah, okay, yeah. Yeah, there's a lot of possibilities on what can be done with these new technologies. And I think that since it's open source and so many people are collaborating, things are speeding up a lot. So we're from Guatemala, you know, like we don't have a lot of resources.
No, but we're a small worldwide community now.
Yeah,
totally agree with you.
but we're able to build all these things because everything is cheap. And actually, we think that since we can build it so cheaply in Guatemala, anywhere in the world you can build it cheaply too, which is good. Because what used to happen was like something would break and they couldn't fix it themselves. Now, since they built it themselves, they know how to repair it. I think that's going also in a different direction.
I have a question.
Thank you very much for the.
Thank you.
What's the raw material?
What's what?
Raw material.
That's just 3D printed. So that you just need plastic.
So what's this area over next door? Is that
Okay, yeah, that's ours too.
Okay.
Do you want to go there?
Yes, please.
Yeah.
Well, obviously, it's grabbing the crowd.
I wanted to know, do you know, I'm a physical therapist. I was watching this whole thing. So are you having somebody to train the patients to actually put it on?
Yeah.
And because the physical therapist knows which muscles come to which way. For example, I want my patients to do flexion of the hand. I need to put the sensors on the flexor muscle, which is the forearm.
Yeah.
So are you involved with
Yes. Actually, that's one of the things that I like, that we're working with hospitals. So this is not like a maker thing, do it yourself. I mean, yes, but you need the software. Okay, so because the thing is, we think that the patients are not just they're going through a lot. Like, actually one of our first patients, he said like he was on to this and he wanted to test it, but then he didn't come back. So we called the wife and asked him, he didn't come. So what happened? She's like, no, like he's feeling very depressed and he's just been sleeping all day and like he didn't come back home either. Like I don't know where he is. So I think that they need a lot of other things like the psychological assistance and everything. And so for the myoelectric, there's a machine that the doctors have and they just put and then they examine what are the muscles that are like the most active muscles. So we use that information to know where to put it. Because since they're amputees, when they cut them, like a lot of the nerves get moved and everything. So yeah.
So you can be involved and you just find out which muscles are more active.
Exactly.
That's where you put the sensor in your brain.
Yeah. And that's per person and how they move and everything. It's for every individual, especially for amputees.
So you design that for individuals. You design based on what muscles are more active.
No, because we just put the sensors in that part. So and also everybody has like for example, depending on his job, they have different usage. Okay. Yeah. Okay, we can.
Oh, no, you can go ahead.
Okay.
It looked like you were...
Okay, so let's start on the other way. Okay, so this seems is pretty popular.
Yes, it is.
Here we're showing off the Oculus Rift, which is just like a virtual reality. So the thing with the Oculus Rift is that it's the headset that you put on, and then you can approach it and see a little bit, but like they feel that they're going through a roller coaster. So I think that one of the things about virtual reality is that if you go to a 3D movie, you don't feel that you're there. And I think there's a sense of, I'm not sure what's the word, but that you can control your surroundings. So if you don't get that, you don't feel that you're there. So you have to be like immersed in the situation. So you look up and you see the sky, and you look down and you see the floor. So that's very important. So we grabbed some of those ideas. There we have another exhibit that people are using just a cardboard. So the cardboard is, I think it's like under $5 maybe, or $10. It's just a cardboard with some electronics, just some lenses and a magnet. And so you just put your mobile phone inside, and that's augmented reality. So they're seeing something when they see that image. So we grabbed those ideas, and then we have the robot. So maybe you can go into the robot there.
Okay.
That's a humanoid robot. So using the Oculus, he's wearing now the Oculus, and however he moves his head, since that sense that of I don't know the word, but like moving and changing the world. That's how the robot moves. So he sees through the robot's eyes. The robot has like high definition webcams, and so he's seeing through that. And the pitch, yaw, roll movement from the Oculus is translated into the servo motors of the robot. You can see that the robot also has a hand. So we're using a lead motion to detect the movement of the hand. We also have like a glove that you put it on, and maybe if you come closer.
Sure.
So there's the glove, and it uses some flex sensors.
Okay.
So those are flex sensors, and it's attached to a hand. So however you move your hand, that moves. So what we're building is you're going to put a suit on, and then the robot is going to be at my it's going to be at my job. So I'm not going to go to my job physically. You're going to wake up, put on the Oculus, and put on this special suit. And then the robot is going to move exactly as I move. So right now it's a color presence robot. So I don't have to be there. Or what are the applications? For example, in Guatemala there are some places that are very, very far away. So we can have the clinic of Dr. Robot. So a doctor in Guatemala City, can just use this suit and examine the patient. And then, for example, if he doesn't know what to, like, he says maybe you need an expert on this other thing. So he would just like transfer the call to another doctor who has all the suit on, and then he will examine the patient.
Yeah,
so,
that's interesting.
So those are some of the applications. And for like further, like after, since the robot is learning all your muscle movements and all your vision and all your auditory system, then you can like show him how to do things. So for example, you can just start sweeping your home every day, and then the robot can learn, okay, so this is sweeping. And then maybe after a year, he can deep learn those behaviors, and then you can just like download the sweeping behavior. And now he learns how to sweep. So that's maybe for the future, but right now, we like you can see that how he moves is how the robot moves. And other people are manipulating here the hands. So yeah, this is a telepresence robot that we've been working on this for like 8 months. So that's the in-move robot, by the way, which is designed by a French guy named Kael.
I thought it looked familiar.
Yeah, so you just download the files and 3D print them.
No, we're
really cool.
In fact, we need to get together. I am working on a VR system using the structure sensor, so that way you have environment awareness, so you can walk around. That's what I'm also developing. And I have a lens system, so during the 3D scanning, look for the structure sensor in my card. So I'll give you my card, and we can have no dialogue.
Thank you. Yeah, we also have some augmented reality things. So when they were seeing this, when they saw certain image, something will pop up. And I think that's really interesting because one of the applications of this is this one. So yeah, you would have to see through these glasses, and when you see that image, then something pops up, and you can interact with it just with your hands. So one of the applications that we're thinking for this is, for example, I have a baby. So when we were going to the doctor, they would scan, you know, but you can't really understand anything. It's just like a black and white blur. And now there's like 4D, but you can't really understand what's going on. Like, it doesn't look very well. So instead of that, you can just put these glasses on and look at your baby. I mean, get the information and then look at your baby full color, and you can like get closer to him, rotate, and you can see him like everything. And even a doctor might, because here we have a car, for example, a Lamborghini. And then using a controller, you just like make it bigger, and then you can make a life size and see how it would fit, for example, in your house. And then you can go inside and look at the controls. Or we have a house, and you can make it like super huge, and then go inside the house and walk inside the house that you're gonna buy, for example. Or you could like have you have your living room and you want to buy something from anywhere, and then you can just like browse their catalog and see, okay, how is this sofa gonna look in my bedroom? And then you can see, oh, it's nice, the colors, you can change the colors, and then you go, okay, this is working. Yeah, those are some of the ideas in the project that we're working on.
Got a lot of stuff going on.
Yeah.
Kind of like my mind.
Thank
So
you.
let me give you my card real quick.
Hi everyone.
There you go.
Wow. All things 3D. Thanks a
So
lot.
actually, I want to invite you on. So do you have a card or a brochure?
Yes, I have it.
the Logitech camera end up being used for?
I'm running a Google Hangout stream.
Okay.
Which is coming through here on a Windows tablet.
Oh,
So
nice.
it'll
Okay.
launch it. And then I have an archive standard Canon.
Yep.
It's a pro version, small camera for archiving, and then has additional footage if I need it. 1080p. This is 720.
Yep.
And then that there is a 360 panoramic camera.
Yeah. And where are you just storing this, or are you broadcasting 3D also?
Not yet.
Not
Nobody
yet, okay.
provides a service yet, but that's what's going to happen.
That's I didn't think so. Yeah, I didn't know if anyone was doing that.
Hopefully soon, so I have to offload it and bring it up.
Okay.
I'm glad that YouTube supports it now, but
Yeah.
they modified something so they're not true cylinder controls anymore. They have 2x curvature.
All right.
But yeah, it's still a representation.
And then you're zapping up with Verizon. I see
I have an
that.
LTE modem on USB right now.
I'm going to take a quick video of your rig here because it's very clever. If that's okay, can I do that?
That's fine.
Okay. I'm going to go on this side so I
Okay.
get you in the light. Well, I got to get your whole thing 3D. Would it be your, oh, your I see what you're shooting.
Well,
right
actually,
now. I
on the
got it.
front of it, it has it as well.
All right, there we go. Very cool. So we got a 3D panoramic camera. Right here is Logitech. That's for Hangouts, streaming.
C920.
Modem right here.
Correct.
Traditional camera.
Correct.
And
Zoom
if we turn around, you've got a
H5
Windows
virtual. And actually,
tablet.
this
One of the
is
Hangouts.
this is a Micro Center 8-inch tablet.
Oh, nice.
Well,
So it's really
important
simple.
is it has a separate USB port. Most of these tablets don't. So you have two USB ports instead of one.
3D. So I'll check out your site too. Nice job. What's your name?
My name is Mike Balzer. I'm the producer and I'm also the founder of Sports Recording.
Very nice. Thank you.
You're welcome. So I'm going to have an additional battery pack here that runs about 6 hours. And then if I did forgot the cable there, I've got two LED light strips here that provide additional front lighting.
Oh, okay. How bright does it get?
Huh?
How bright do the light strips get?
About 1200 lumens.
It's impressive. And where did those come from? Are they just
Believe it or not,
stacked together?
It's not. They're actually polarized.
Oh, okay. Because I saw Snap-on has a little portable rig they're selling at Costco, and I thought maybe a
I bought some of those too, but no, these are just well, yeah, exactly. They're not bright. And these are 12 volts. So I have an additional power pack to supply, but forgot it was to it. But luckily we've got diffused lighting and we're pretty good with that. So we can.
And
Thank
you
you.
have sponsors, advertisers?
Nope,
It's just a hobby?
No, I wouldn't say that. I've been doing, put too many hours in it, but we've been doing it about an hour and a half. I've got a co-host, Chris, and we do a weekly show called 3D Review, and then we do several interviews and monthly roundtable discussions on 3D.
Good. I'll check it out.
Thank you.
Nice job.
Thank you.
Hello.
Hi.
What are you showing here?
Actually, I am showing you right now. This is a live streaming system on Google Hangouts on air with additional HD backup as well as a 360 panoramic camera. So what I'm doing is going around and interviewing people.
I see. Oh, okay.
So thanks.
Okay. What is this, sir?
I'm live streaming the event through Google Hangouts, and also I'm capturing it in full panoramic. That's what that camera's for, and talking with people.
Thank you, sir.
So right now it looks like we are in the super dry science area. And again, like many of the things here, I think they're very family oriented. So bring your kids, come in, and enjoy the experience with them. I think this is super important. This one, my children are younger, like this existed, and obviously, pretty much if you look at it, people are taking things that they experience with children, hobbies, and so forth, and making it available for a larger group of people. So we're going to take a quick spin around here, and then we're going to head out to another area. So we are in the major comfortable area, where a lot of the 3D printers, as you see here, is personal CNC. Actually, let's see if we can get in the top 10. Actually, these are the same people that we saw last night. I'm sorry?
What is this thing?
It's a live streaming broadcast system.
Of the MakerFaire.
I'm sorry?
Of the MakerFaire.
Yeah.
I was kind of disappointed. Like last year, I had a camera. It was a disposable camera because I didn't have a digital camera, but I just didn't develop. I think I threw it away. And I was like, that's because there'd be everything's going to be on YouTube. But there really wasn't anything on YouTube. Only like 5% of the stuff was on YouTube. We need to see all of it.
Well, that's my goal. And right now it's streaming live.
Oh, are you?
Oh, is it audio or?
Oh boy, impromptu.
Yep, that's how it works. So tell me, I think, were you guys at Rio 2015?
Say that again?
Were you at Rio 2015 with your...
No, I don't.
Okay, well this is another one. So what makes this one special other than personal scenes?
Well, essentially what it is that this is a mill that's capable of anything that a full-on production industrial mill might be capable of. Whereas, is that better? All right. This mill is capable of anything that an industrial-sized mill might be capable of. It can cut metal, it can cut steel, platinum, the high-end stuff. We're milling plastic today because it's easier and it's faster. But it allows makers to make real products rather than 3D printing is fantastic for prototyping, and sometimes you can make real things with it. But then eventually it comes to a point where you need the rigidity of metal or other materials that you just can't get out of a 3D printer. Unless you're spending $1 million, which is cool too. But
well, the other important thing is, and you may have mentioned it, is speed. A lot of people don't realize additive is still very slow. CNCs are incredibly fast.
Yeah,
And I found this out through working with some dentists using SLA versus a CNC. It seemed to be more accurate and faster. So I don't see it going away anytime soon.
Yeah, exactly. I mean, and that's the thing is, I mean, we've got aluminum parts. It takes 20 minutes to mill out an aluminum part, and we're talking numerous features, threading and everything. Numerous features and all kinds of threading and stuff. And so that's part of the advantage of this machine. And the fact that you get it and it shows up in a crate, it's user installed, so people learn as they use the machine and as they build it. And then the fact that it uses regular power. So it's a regular outlet. You can plug this in your garage. Yep, it's a 110. We have a larger mill that's 220, but even that's pretty standard.
Yeah.
So, yeah, exactly. We try to make it as accessible as possible. And you know, one of those things that we hear from a lot of beginners is ease of use. People come into it and they understand it, and it's pretty quick. If you understand the beginnings of CAD and CAM, you can very quickly get on the machine. So and the machine can be put together with no special tools.
So let's say from a design standpoint, what's the difference between that and additive?
Between the CNC and a mill and an additive? Well,
from a design perspective.
From a design, sure. Well, that's the thing is, I mean, like I said before, rigidity is huge. But a big part of it too is like this ABS plastic that we're milling. I mean, that's essentially the stuff that's coming out of a 3D printer. But what happens is when you put something through a 3D printer, you're melting it, and that can dilute the composition. Right. And so with this, you're coming with solid plastic, and you mill it up. So our pieces, if they were 3D printed on a machine, the exact same piece, it wouldn't be as strong on a 3D printer. Because you're essentially, I mean, it's rudimentary, but you're super gluing layers together.
Yep, exactly.
Right. And so this, you're never breaking it down.
Okay, well, the other thing, and maybe I didn't approach the question well, obviously, since you're doing subtractive, from the design perspective in the CAD software, how does the mind have to relate to that? For instance, in my case, I've never done any CNC, but I've done a lot of additive.
Oh, sure.
So what do I need to learn?
Right, no, and definitely, and really, that's the big step in between, you know, with 3D printing, you have CAD, 3D models. You do the same thing here. The only difference is you have to have CAM, which is computer-aided machining. So essentially, that teaches the machine the right way to go. So you have different tools, they have different lengths, they have to be spun at different speeds, all that sort of thing. And then it always changes depending on the material that you have on the mill. So all of that's done in CAM. And then it outputs the same thing that a 3D printer might output in G-code. And then it reads it just like a 3D printer would. But the difference is that CAM software.
Okay. That's an additional piece. So if you're using CAD, you have to find something that will do CAM as well.
Right, exactly.
And from what I've heard, Autodesk V.360 does CAM as well. Right?
That's exactly, and actually we just started a partnership with BioBot.
Oh, excellent.
So yeah, with every one of our machines, the Autodesk V.360, we get a free year with the package.
Okay, well I do Fusion 360, so I'm already licensed with it. All right, so what's this going to set me back?
Well, the machine as it sits right now, I mean, this has all the bells and whistles. It's got an automatic tool changer, the enclosure, things like that. This sits at about $17,000.
Oh, okay.
This starts base at about 7. And everything that we sell is modular, so you can buy the base and build up, and everything's a la carte. So you don't have to buy any special packages or anything like that. You just build as you want to go.
So what? You mentioned what's the build size? Speaking from an additive.
The envelope?
Yes.
Yeah. Okay. Yep. So the travel on the machine, it's about 14 inches on X, 7.5 on Y, and 13.25 on Z.
Okay, that's still fairly good.
Yeah.
So if you wanted to keep this in mind to the audience out there, if you're looking at a commercial printer like a Fortis, which is $40,000 to $50,000 and up, you're getting something that provides, in some cases, better accuracy, more durability, even though it's subtractive for about 1/3 the cost.
Right. Yeah, and that's the thing too. Is I mean, the next step in the machining line, you're talking about a mill that's $40,000 to $50,000 at least, and it's gonna have to have dedicated power. It's gonna have to sit in a warehouse. This you can put in your garage. You can put it in your basement. It doesn't need dedicated power, and it operates just as well. The only difference between a major mill and our machine is that because the machine is smaller, it's got slower speeds, so milling heavier metals take a little bit longer. But otherwise, I mean, it's for makers. They don't need it to be a production machine. We do have customers who use it as a production machine, but that's why we're here, is to show it off to people who can really use it.
I've been working with additive for 2 years in design, printer design for 20 years. But I've always raised to have a CNC, so maybe I can afford one now.
We like to make.
Chris, thank you. You got a business card or something?
I do. Yep, absolutely.
Excellent. Would you like one as well?
Yes, absolutely. Yep.
You can go out to Google Plus. I think you can actually go out to my YouTube channel and watch it live right now.
Oh, fantastic. If it was like a short delay?
It was probably a little bit, but when you tune in, since I'm already moving on, it'll be like it's there.
Yeah, rock and roll.
Okay.
Well, thank you.
Thank you, Chris. So that was Cormac at the personal CNC. And as you realize, it's very expensive. Little plastic router and laser. Yeah. So we have it. Wow, okay. So how can you print in metal? So that's a low temperature alloy. Okay, very cool. Now, being low temperature, it's still much hotter than standard plastic. So what's the temperature that required? Okay, so you got full, wow, those, you mind if I take a closer look? Wow, so all metal extruders in hot end, correct? All metal hot end in extruders? Okay.
And also modules for both the router and the laser.
Oh, okay. So if I don't mind, how much does this cost? Oh, very reasonable. Okay. So do you sell this entire printer here? Okay. So it looks like it's well constructed. Are these steel or aluminum? The rails here, are they steel or aluminum? Steel. Yes, I noticed that. Very nice. And so I noticed there is even a heated bed.
That will be an option.
Okay.
Not only will it be often a heated bed, but also 5 axis.
Oh, really? So you can do CNC.
You put these in
Very interesting. Very interesting. Okay. So it looks like it's got a very large bed. And what's the size and volume? Wow. That's impressive. Very impressive. You got a business card? I'd like to have you, I'd like to email you and have you on the interview.
That'd be great.
Yeah, this is exciting. Really exciting.
That's my biggest partner. He went out and talked to you from that.
Okay.
He's the one
Okay, well, I don't have a lot of time, but I will email him if I'm anything.
I'm John.
I'll email both of you. And then, yeah, we'll get you on. Yeah, I'd love to know more about this. It seems well qualified. Well made.
You'll be here back in about 5 minutes. We want to stop by.
All right, if I come back around, I'll see you. Thank you. Move right on. As you noticed, if you watched any of the MakerFaire yesterday, we probably have 10 times the capacity. There are people coming out of everywhere. I'm glad that I took a shutter today. Because yesterday it was maddening trying to find a parking space. I literally had to drive, about a mile away from it, so it was a long walk. Can't say that I'm energetic today, so I followed along with my enthusiasm was lame. But as you can see, it's really just full of stuff out here. I have footage from some of these booths from yesterday, so I won't go back over it.
You stay at the same place, okay?
So we'll walk down. Let's go over here and see if we can get an opportunity to talk.
Yeah, big part for this. Yeah, this is a 1/3 scale.
Hi, do you mind talking with me a little bit?
Sure.
I'm from All Things 3D. My cable's kind of twisted down.
The only reason it looks like a pyramid is because we optimized this to print on an FDX under 45 degrees. But there's no reason,
Thank you.
wouldn't make it a box.
Okay, so hi, who are you?
So I'm Skylar, and that's Carlo.
Hi,
And we're with Walking to Bio.
Okay. Interesting background there. So what do you do?
We do 3D printed hardware for biology, equipment for biology.
Oh, okay.
So an example is a 3D printed incubator. This is a scale 1/3 version that you use for an incubator like a cell culture. You put your cells on that, and you control the heating of it with a Raspberry Pi.
Wow, okay. Okay.
Plug in all kinds of heating elements, cameras, temperature sensors to monitor this device. All of that data, the Raspberry Pi then sends to the cloud. We provide the services, logging and analysis, predictive failure, all of that, this kind of stuff. But the design for this is open. It's totally available for anybody to get and download. And if you use the right material, you can even print this out in a version that's safe for food at a high temperature. So this is the full size, this one there, it's 1/3 size. It's about the size of an easy bake oven or a Foreman grill. Right? So we see a really clear bridge between 8th, 9th, and 10th graders using these devices in home ec, and then using the same interface, the same device in bio class a year or two later, and then using the same device in college too. Now, I would buy a 3D printed grill because that's cool in and of itself, but to be able to then put it in the dishwasher because it's safe for dishwasher, and have my kid in college come home and do an experiment for his bio class in college on that same thing, that is a win-win.
That's right. So what kind of customers do you work with?
We have a couple of pilots right now. We'd like to get it in the hands of students and schools as much as we can. We have some corp-to-corp, I think, that we can do, like business, B2B type of stuff, at scale, this kind of thing. Consumers aren't really going to be interested in a cloud offering service, although monitoring my grill from my smartphone, that would be awesome. But for biology, for incubators, I think that most people in research and citizen scientists are mostly going to want to hack on it themselves. But a corporation that's doing a production line where we can 3D print out a larger version of this, for them, they're going to want to be able to know when the hardware's going to fail. They're going to want predictive failure. Our temperature is sensitive enough, we can tell when the room to the door is open, or the door to the room is open. So we can give them all of that in the cloud offering, notify them by cell phone when something changes.
Very, very neat.
Right? It's basically
That's a very useful.
the
So is there any reason why you picked the pyramid, or that the normal
Yeah,
shape?
so that shape in particular, the pyramid we picked, because it's a self-supporting structure for a 3D printed FDM style printer, like a MakerBot, but a bigger version. We didn't want to have any support material. That design is only, we picked that one because it supports itself as you build it. We fully expect that the community, because it's free and open to download and modify, will come up with a better design. We'd love to actually use some generative algorithms to come up with whatever the most optimal design is for space. And we think that that's probably a good application for this. But we're curious to see what people come up with. However they want to build platforms and bolt them together, come up with some other design than that. That's only the constraints of the printer we use.
Other example. Thank you very much.
Thank you.
right? Because, you know, like you have cells and this, you need to see that's like low speed, low torque, which is exactly what I think.
Give me a little bit of an overview of Shapeways. I'm actually
we'll get our PR person to do it.
okay. Hi, how are you?
Good.
I'm from All Things 3D.
Okay.
I actually know Charlie. I was the moderator of the panel at South by Southwest,
Okay, very
and he
cool.
was on it. So I have a little bit of experience. Plus, I have things made by you guys. So one of the things that you guys have done something new, because I think a lot of people already know who you are, is that you're making, or you have new materials now. Is that correct? And so can you kind of talk about that, plus any other type of services that you've added in the last few months?
Yeah, absolutely. So we have
Okay. Lighting isn't that good.
Okay. We actually have over 50 materials now, and so that includes all of our plastics. We have full color sandstone. We're piloting porcelain right now, actually, where we're printing
Wow,
the molds
okay.
for porcelain. And we've got a bunch of different metals as well. So we recently introduced our precious plated metals, so they're a little bit more affordable than if you're buying something in gold or silver. And so then overall, we've got about 50 altogether with all those different finishes that we do.
Wow, really neat. You know, what's funny is that I've taken your sandstone and I use an epoxy varnish, and I create my own little
Yeah.
thing out of color. So I want to take that back as a tip to the scientist. So it's pretty neat. I noticed you've got some quadcopters back there.
Yeah.
What's the reason for it?
So we actually recently partnered with DJI, and we're doing a contest now with our community. So we're asking designers to design an accessory for a DJI drone. We actually have Adam Savage of Mythbusters will be judging the contest.
Oh, really?
Yeah, and so he'll pick the winner, and the winner will get a DJI Phantom 3, as well as $1,000 in Shapeways printing credit.
Wow.
Yeah.
So is he actually coming here?
He's actually not coming here. We wish he could. He's in the area, but he's a huge fan of bakers and
I know he
making
is.
fun things.
He
and
talks about it all the
he's
time
been
on his
great.
own show. Oh, really cool. Okay, well, thank you very much.
Absolutely. Thanks for stopping by.
Thank you. So let's go over here to the Up Plus 2 and the Up Mini. We haven't really talked to them, but they are one of the more popular printers because of their reliability and their accuracy. In fact, the Up Plus 2, if I can get in here.
No, she's giving them away again. Oh, okay.
Hi.
Got enough gear?
Huh?
Got enough gear?
No.
Hi.
Wow.
That's crazy.
Maybe you have to interview him.
Oh, you're interviewing?
Yeah, please.
Oh, sure.
Hi. So I'm a fan of your printer. I don't have one personally, but I know that this thing here, there's a lot of people that love it. Can you kind of give me an overview of your printers? Obviously, you got some new ones.
Yep.
So maybe we can start with the Up Mini and then move up to the bad button.
Sure.
So go ahead.
So we represent the Up brand of 3D printers made by Tier Time. So our original design was a classic design called the Up Plus. And we've been working on that for 4 or 5 years. And we think it's perfected. So what we've done is we've tried to make it a little less expensive, and we've created the Mini, which builds the same resolution, high resolution parts as the Up Plus 2, but it's now now it's only $5.99.
Wow.
And we're printing a part there now. Yep, $5.99. Now people seem to like the enclosure on the Up Mini, so we decided to incorporate it to our newest machine, the Up Box. The Up Box has all the features of the Plus and the Mini, plus a few more like auto calibration, a HEPA filter, fully heated chamber and build bed. And the build area is gigantic. It's 8 by 10 by 8. So that's our Up Box. It's available for shipping in about 2 weeks.
And a drum roll, how much?
The
drum roll, please. How much is it?
Oh, the roll for the filament?
No, how much does it cost?
Oh, the cost is...
I'm pretending
sorry.
like I'm rolling a drum.
And the cost of the Up Box is $18.99. $1,899.
Deserved enough.
Yeah, and the Up Plus 2 is $12.99 and the Mini is $5.99.
I remember that obviously when they first came out, I think they were like $1,200. And so obviously you kept up with things, kept the prices good, but haven't in any way lowered the quality. And I'll tell you what, that unit back there is impressive.
Yeah.
Were you guys at CES?
Yes, we were.
Yeah, I must have missed it.
We had a really early prototype then. So.
Well, it looks really good.
Great.
So $1,800 for that.
Yep.
$5.99 and
$12.99.
$12.99. Sounds
Great.
good.
All right.
Glad I came by.
Thank you very much. Are you internet broadcast?
I'm doing it right now. It's doing on air.
Oh, really?
Yeah, and we've been for 2.5 years. I'm going to give you my card.
Great.
Long interview.
Wow, where are all your batteries?
I'm around my waist.
That's awesome. Thank you.
I've got a unit right here. And then when I'm running my lights, I've got a 12-volt system there. And everything else.
Very impressive.
I got a laptop in there. Can you make sure it's pushed in there?
Very zipped up.
Okay.
Very inside.
Okay.
You're good. Yes, I got it. I see your thing.
Okay.
It's totally in.
Good, thank you.
All right, thank you.
That was interesting. Wow, some really good prices here. Somebody that I started out with in 3D printing, we pretty much gave up every one of these things that kept out. Yeah, looks like we got some other unique things over here. There you have two favorite robots. There's the XYZ printing. So as you're probably aware of, if you watch the CES, we at length talk to the people out there at XYZ. If you watched the show last Friday, they are one of the #1 sellers on Amazon and at Best Buy. They are really coming on strong because they have a lot of low-cost 3D printers. If you remember, we also had Simplified 3D on. They are now the slicer of choice. I think it is packaged with it now. So they have moved from providing some of the lower, I should say, manufacturer cheaper 3D printers to some of the more inexpensive, easy to use printers. Now, I think some rumors, maybe if I get a chance, I'll go in there about them providing a proprietary cartridge but maybe I'll go in and ask him personally. And if you look in there, this looks like the SLA printer, which looks a little different, maybe not, from the one that they showed at CES. If you remember, it was $2,000, $2,500, which is interesting, but let's see, yeah, it's actually, oh my gosh, it's lower now. It's $1,499. I don't know if that is a show price, but if you remember the Form Run, which is, hey, you remember me? Hey, so yeah, go ahead. We're running right now.
Okay.
Sorry about that.
Hello, welcome to XYZ's booth.
Yeah. And I remember you. You actually talked for me when I was at CES. So.
Great. So I'm Brent Payne here introducing XYZ Printing's newest Da Vinci Junior. And pricing at $349.
Now, was this the same price at CES?
Yes, correct.
Okay. Now, I noticed when I was talking to my software, the Nobel 1, did you have a higher price? Did it drop, or was it always $14.99?
Oh, they were always $14.99.
Oh, wow.
Yes. The Nobel will become available in June.
Okay, well that's really important, and obviously the quality looks better.
Right, so the resolution is 25 micron.
So, what you may not be aware of, but we also talked to the CEO of Simplify 3D, and he told us that we have a partnership with him now as your slicer. Is that correct?
That detail perhaps is outside my department, so
okay.
I do not know, but
Well, I
it's
know
definitely
that.
a possibility.
So yes, it is happening. It's been licensed, and for my audience out there, one of the things that detracted people from buying your printers is not having a real good slicer. Well, you now have a solution for that, because Simplify 3D, in my opinion, is one of the better ones out there. So you've got a low-cost printer with an excellent slicer. And plus, I don't know if you saw the review that just came out. They're one of the top printers being sold on Amazon.
Right, definitely. XYZ Printings is currently the #1 selling 3D printer on Amazon. Also the #2 market share in XYZ.
Yep, and they also did a study on Best Buy. You're up in the top 3, I believe. And what else? Walmart. You saw these at Walmart too?
Not at Walmart, but mainly Best Buy, Amazon, Micro Center, and Newegg.
Okay.
Yeah.
Like I said, I've got to get myself. You know, if there's a possibility of getting a demo unit, maybe an SLA, that I'd love to review it. So whoever I can talk to about doing that.
For the reviewing the Nobel?
Yes.
Yeah, definitely. You can definitely speak with me in regards to that.
Okay.
We'll be happy to figure out.
Okay, can I get your business card again?
Yeah.
I may have lost it because I've been using your standard contact form, and nobody ever contacts me.
Unfortunately, I don't have my name because I got it now and my company didn't put it.
I think we did this the last time. How about just putting your email address on the back of it?
Quick question, what's this for?
It is a panoramic camera.
Oh.
So I'm getting a full 360.
Like the MakerBot.
Yeah, I still record it.
That's very true.
And then I'm live casting through Google Hangouts on air through this Windows tablet, and then I'm archiving with an HD camera.
Excuse me, sir?
Yes.
Is it okay if you interview me over this stand?
Over here?
Over my stand over there?
Oh, you have a stand?
Yes.
Oh, I sure will. Let me finish up there. You know.
I'm helping kids become CEOs, so I think I might be.
Okay, that'll be cool.
Thank you.
Uh-huh.
Because I wanted to be on TV, not really TV.
Well, you're on the internet. You're on YouTube. That's even better.
Hangouts. So if you could interview me, that'd be awesome. Thanks.
Excellent, thank you. All right, I'll email. My name is Mike. Actually, let me give you my card again. We've been doing this for a year and a half, actually almost a year and 3/4 now. Okay, that's Chris Kopak, my co-host, but the email goes to the same people.
Okay, great.
So yeah, I will contact you. I would really like to know more about it and possibly give a good review.
We'll be glad to definitely have a review.
Sounds good.
All things to do.
Thank you.
Yeah, thank you.
Well, I hope that works out. As I said before, that is curiously very similar to Form 1. So I wonder if the guy works just as well. So we're in the build tech booth, and it's funny to be able to apply a face to it. So, and I have promoted their product, and I'm a little busy right now, so on my way back I'll cover that. Hey, look who it is over here. It's John. Hello, John.
Hey, how's it going, guys?
As we're speaking, we're live.
Awesome.
So, hi, John. What are you doing?
Hanging out in MakerFaire Bay Area.
Yeah, another long trip for you guys, huh?
Yeah, this time we didn't drive. We actually flew out.
Oh, that's good.
First time we didn't make that long 5-day drive.
So we got here is the Mad Max now.
Yep, we got a Pro Stock Max and Orion up here on the table. Some print samples, filament.
Where's your Mini at?
The Mini's not quite ready yet.
Oh, okay, I was going to ask you about that. 6 weeks?
The Eris.
Okay. And the price again?
$5.99.
$5.99. I look forward to that, as we talked about before. I have, as I told you, an interesting idea for it, so keep me in the loop on it. So how was your Indiana fest out there?
Yeah,
I mean,
so
it was
Midwest
crazy,
Rip
huh?
Rap, we had a little problem with our radio broadcast, we call it.
A little bit.
We're not known for having great Wi-Fi. The festival, we ended up with about 1,300 people. I think,
Wow, that's good.
around the weekend. So we had a really good turnout. Lots of people came. It was really neat to meet up with Sanjay and John from V.360. MakerFaire guys. Boy, there's a dozen people.
I know.
Can't remember them all off the top of my head.
Well, I took some of your footage where you went around in first-person view and showed it on the show. So yeah, it looked like it was exciting.
It was a blast, and we're looking forward to next year.
Well, maybe not.
Yeah, oh,
So-
it'll be somewhere. Somewhere hard to get to again.
Yeah, in the middle of the cornfield.
Yep.
Well, hopefully, maybe this
I've
year,
always
now that I have enough time to realize it, I'll make it out myself.
Yeah.
Then we won't have to worry about any videos.
Yeah, we'll have to
I'll put a
record
big
it
antenna
and
on my back.
upload it that way. It might work out better.
Okay, well, thank you, John.
You bet. See you guys later.
Bye. So, that was John. We've had him on several times.
Down for a second.
Yeah.
And,
You guys sit there and I'm going to check something out. What's up?
wow, I am a little surprised.
Da faz parte.
It's interesting. Some of these shows, especially MakerFaire, seem to bring out quite a few of the, I'm going to say the lower end, but maybe the lower marketed versions of 3D printers. Looks like they're busy. I'll come back later. But I have to look into it. One thing that I have noticed belongs to the quality of some of the kind of lower end, the lower production or smaller companies 3D printers. So here we are at Formlab. We've had them on before. If you remember correctly, they have these Form 1 So hi, you guys want to talk a little bit?
Let's more talk. Just a moment. I'll be with you.
Okay. How about I go down further and come on back? There he is. So we have this young gentleman here who wanted to get an interview. Hi, Zach.
My project is I'm CEO.
You're CEO of what?
I'm CEO of my green products, and I'm helping kids and
$10, huh? Wow. Pretty cool. So make sure anybody who's watching this later on to come on by and what's your name again? Zachary, that's right. So pretty neat here. So who's this guy here? Is this your assistant?
That's my dad. He's my secretary.
That's what I thought. Pretty cool. Well, honestly, your dad, your secretary, has got you on the right path. All right. So very cool. So, I'll look you up and mention you on my show this next Friday, okay? All right, thank you.
Hi.
Hi. I am.
I think I might have something that would interest you over there.
Okay.
Want to swing by? We're called Imaginary Spaces. Whatever you come on,
Okay.
it'll be right over there near the entrance on the far side. It's called Imaginary Spaces. We have a carnival, so I think
Okay.
you definitely
I
be
will have
interested.
it. Yes, please. So you guys are a long way. Hi, want to talk a little bit? So this is a maker school in Budapest,
Yes,
Hungary.
we came here from Europe to introduce our maker school. We are on the preparing phase, and we will open in 2018. And we came here to make a direct contact with Maker Media to understand and see everything what Maker Media do here. That's why we are here.
What do you think so far? Crazy, huh?
Actually, it's a very wide range what we can see here about makers and the way of thinking of maker movement here.
Now, if I remember correctly, isn't there a company in Hungary that does a 3D printer?
Pardon?
Do you not have a company in Hungary that makes a 3D printer?
3D printer, there are, I think, 2 companies.
I think I interviewed one of them. It's actually a pretty neat one. I can't remember the name of the company now, so that's why I came over here. So, it's funny. All around the world, we got makers and 3D print manufacturers. I've been doing this for about a year and a quarter now, and I interview a lot of different manufacturers. So it's a small world, as I say.
Yes.
Well, I hope you enjoy San Francisco and get the most out of it. How long are you here?
We will go back to the East Coast tomorrow.
Okay.
And we will check some maker spaces there, and next week we will go back to Europe.
Great. Well, enjoy your trip and whatever else they say. Safe trip to the house.
Thank you very much.
Thank you. So we're going to turn back through here. Okay. So what is this? Go Vikings. I saw this yesterday.
This is Irvington High School's robotics class. So my students have projects that they work on all through the year, and it's separate from the curriculum that I teach. Each kid gets to pick a project, and so we're showing them off at MakerFaire because I teach the best ever.
So is this a local high school?
It's in Fremont, yeah.
Fremont, okay.
Public high school. We're the only robotics class in our school district. So Alan made the Tesla coil.
That's cool. I made one too when I was your age.
That's awesome. So we have the earrings that kids have designed. Some of those on there are little maker earrings that we didn't design. We got them here, but then we made them into earrings.
Cool.
Daft Punk helmet.
Yep.
What we wear in the frame so that it doesn't hurt people. Another one of my students, Andrew, designed that.
Wow.
He built the frame himself. We 3D printed the parts for the quadcopter in our classroom on our 3D printer.
Okay. What type of 3D printer do you have?
I have a Robo 3D and a MakerBot replicator too.
Okay, I have a replicator too as well. I've modified mine, put a heated bed on it.
Nice. Steven is back here with the laser cutter, and he just made these little MakerFaire earrings. So he just printed another one. I just cut out another one right now.
So you seem to have a lot of passion for it. Other than being a teacher, which is not a small feat, as I've done it for several years in the military. But what is your background?
My degree's in math, and I taught math for 8 years, and then got tired of people, mostly students, saying, we don't really know why this is useful and why we are supposed to learn this.
That's an excellent
So started doing a little bit more engineering stuff. Asked the principal at my school 2 years ago if I could teach a robotics class as part of the curriculum as an elective. And he said, totally, yeah, get it ready for us. So I put some curriculum together, and here we are 2.5 years later, and my class has been going for 2 years, and my kids are amazing.
Wow. No, this is fantastic, and I know I did I do monthly what I call a roundtable discussion. And we did it on 3D in education, so we had the CEO of Ultimaker, a couple of people from Canada, so we had a different perspective of how the educational system are inviting 3D, this type of stuff in. It's much different in Europe. They seem to embrace it better, as well as in Canada, and we're finding in the United States it's more of a personal, like people like yourself that are bringing it in. In my town, I tried to introduce it in the library system, and they wouldn't take it because it didn't have anybody to operate it. So,
you know, it does take a certain amount of maintenance and work, and I mean, my MakerBot, I've taken it apart and put it back together 4 times because different parts have failed, and you have to be able to fix it. But it's so worth it because the kids just love the 3D printing. We scan, this one's me, so I don't know if you can tell. We scanned the whole class, and we're printing the whole class, so we'll have the only 3D printed class photo on campus.
That would be cool. So what type of scanner are you working with?
This was done with a Kinect Xbox.
I design and develop software for the occipital structure, and I make a lens system for it to give it about the same color as an Artex scanner.
Cool.
So not only do I do that, but so I'm releasing it out probably end of May, early July, June.
I am going to get a 3D scanner, like a good one. The Kinect belonged to a student. He brought it in. So I need to get a good scanner for my room next year.
Look for a structure sensor by occipital, $375, and then go out to Slow 3D Creator, which is my site, and I make a lot of accessories for it. Cases, it's iOS, plus you can use it with PC software and Mac software, so that you can use the power of the GPU and node machine to do some really nice scanning. So go out to my site, you can see some of the results.
Okay, all things 3D?
All things 3D.
Awesome.
So thank you very much.
Thank you.
Glad to see people like yourself doing this. Printing and a lot of things like that. Well, Lozbot, like usual, has a huge crowd. I don't know if I'll be able to get in there.
That's a whole studio.
Yeah, it's actually streaming live as well.
Streaming? Oh, sorry.
That's okay. No problem. Well, we'll sneak in right here. Well, as you know, my co-host Chris is very enthusiastic about Lozbot. In fact, he has the Taz 4 and decided to get a Taz Mini. So he's been converted. It's almost like a religion with many of these printers. And he obviously has taken the pill for Lozbot. So I'm not going to interrupt him. We know a lot about him. They make a great printer. I am very surprised at the number of 3D printers. I think we have more this year than last year. I know that Ultimaker is here, obviously MakerBot is here. Yeah, there's just a lot of stuff going on. This thing just keeps growing. I'm not even out of this first 10. So what time do we have? Well, we got 3:43. So we'll see how long I can continue to manage this, but we'll just keep moving.
my shop because I'm older and I want to use my age.
Can we kind of talk about the printers?
Let's get the CEO over here. Yeah, we got Brooke. Brooke. He's the man. Hey, Brooke.
Which one's Brooke? Okay, well he's talking to somebody, so until then, you can talk about it.
I got like a cold. Hey, Brooke.
That's okay. So nobody else can talk on the booth? Okay, well, thanks.
Yep, there's this really
Well, we've got 5 people hanging on the booth, and none of them want to talk. And obviously the CEO, I don't want to interrupt him from what he was doing, but let's keep moving on.
That's Dennis. Hi.
Hi.
Oh, you're not going to photograph me. You're going to wait till Dennis gets back. He's in the bathroom.
You know, that's what everybody says.
Oh, well, too late. Well, Dennis will be back. I just said he's in the bathroom. He's in the bathroom. Have you interviewed?
So you don't want to talk?
Not really.
Okay.
Well, I will if I have to. All right, I'm going to live stream.
Yes.
Well, we're live
All
right
things
now.
3D.
Yes. So what do you do?
Hey, Andy. Right up your alley. Come on over here. Everything. This is the king of all things 3D.
Who is the king?
Andy Filan.
Oh. Hi, Andy.
Got that history.
Okay. So what do we got here?
Well, there's a number of printers here. You have the idea printer. You have the video printer. You have the upper printers. So you have a whole spectrum of printers here that represent some of the more cutting edge machines that are here in the world.
So are you part of this booth?
He's one of my biggest advisors. It was part of Dave Martinez Ventures.
So what do you actually do as far as not only printing, but
I do 3D design and printing. I've been doing 3D design and printing for the past 15 years.
Okay.
I work with a company called MakerFaire. I actually put the printer
okay.
on the ISS.
When I was at Rio 2015, I had an opportunity to talk to you guys there. Great.
I use 3D printing routinely. I 3D printed for people. I've 3D printed components that have gone into space. I've used 3D printing to evaluate ideas.
It sounds impressive, and I probably should know who you are, and I don't, so I'll have to go look you up. So essentially, you've got some history. It's interesting, the professor at Cal Poly actually did some studies with the initial, maybe like 15, 20 years ago, the 3D printers in space. So obviously, you've taken that even further. So anything else in the future? I know that the international, the NSA is going to be putting up something, PLA or anything?
Yeah, I mean, really 3D printing is still an untapped area. The chemistries, the designs, everything, it's just in its infancy. We're looking at hand crank Model Ts. The idea is that you can print living tissue, that you can print foodstuffs, or you can print metals. No one has really cornered a standard on any of it. I mean, there are some really things right now, but they're changing as we talk.
That's true.
Yeah, some of the interesting things we're talking about, working with Andy, is that we just started talking about it's time for us to print prosthetics and make prosthetics a little more engineering and a little more affordable to make the use case scenarios for people with those injuries and those prosthetics to be able to live better, maybe go in the water more often, and print some prosthetics that they can do all that with. That makes their life easier, so they're not doing it all the harder. How do I know that? I have one. So working with Andy, we've talked about it, and we're actually going to
start using this machine right over here, the idea printer F100. I call it the Bigfoot of printers. It just came to me when I looked at it. It's pretty awesome. You see the size of the hand and the print bed there. And I think we're going to start there with that, and who knows where it's going to take us. We hope that we can help a lot of people that have ill-fitting prosthetics and be able to make their life easier. That's one of the things that I like to do for people. We can change one person's life, maybe we can change the world.
So are you familiar with the Enable movement? The Enable? Enable?
I think that's something down the line we're going to look at. First we got to get started. We have the means and the tools now to do it. And with Andy's help, I don't think there's anything he can't do. So I'm just that guy that talks to Mike and has that great idea and vision. He built it out and has a better vision. So together, maybe you'll go to space with prosthetics.
They also look into Unique. They're out of Spain. They also do prosthetics, and they try to glamorize them. Just as part of a free presenter out at Stanford, and he's one of the group out there.
Oh, I'm sorry, I couldn't hear you there.
Yeah, I know, it's kind of hard to do it. I was at Stanford the other day on Thursday, and there were two other presenters by myself. One who's doing bioprinting. In fact, they're over in the Stanford booth, and it's a very compact unit, so you're talking about bioprinting. And then the other one is doing prosthetics, but customizing them and using art to make them more fashionable from a company called Unique. So those are two things that I know of. I've been doing this podcast for about a year and a half now, so I've had an opportunity to talk to a lot of people. One of the reasons I'm here is to talk to some more people. Do you have a business card? And I'll give you my business card.
I think the other thing that's exciting is...
Did I get you good people?
Huh?
Did I get you a good person
Yes,
or
you did.
interview? Awesome.
The cost of the machine is, about a third of the cost of a prosthetic. So that's what's exciting
I
too.
know. And that's one of the things he pointed out. He's able to make something that normally costs $20,000+ for $5,000 to $8,000. I mean, out of carbon fiber that we're using some obviously higher-end printers. But what you can do with these things now, and the Enable program and what they're doing with children who obviously have deformed or amputees, because then they can grow with them, make new ones, because it's cheap. Yeah, it's really exciting. Look forward to I'll email you and maybe we can have you on as an interview as you guys progress with your ideas. Thank you very much.
That's good stuff.
So I talked to them yesterday. I've got some offline footage. It's Microsoft 3D printing. But, I haven't even gotten none of this temp yet. I'm going to go talk to one more person. I also talked to Dremel. They have actually done very well. Become very popular.
And all the stuff that isn't
the printer
melted or glued.
$8.99 or $9.99. Can be bought at Home Depot. But it also can be, I think they're going with some other people. So look for that brief interview. I'm going to upload it later on. Excuse me. Hi, I had somebody hunt me down to bring me into your booth. So
Yeah,
I'm from
sure.
All Things 3D. So if you'd like to kind of give me
I can give you a demo of what we do.
Okay, if you wouldn't mind taking this, hold it about 2 inches.
You want to take it? I'm sorry.
Alright, so we're Imaginary Spaces.
we allow you to do is you can create any living space that you can imagine and then 3D print it. For example, let's say you want to build your dream home or any bedroom or room in your house. What you can do is really easily edit these rooms. So maybe have a section here, add a section over there, add some more stuff here. You can edit it really quickly on the fly. So you can add windows, add doors, all kinds of cool stuff really easily. But even once you got that, it's so hard to get a real idea of what it would feel like to live inside. So what we allow you to do is we give you a first person view, so you can then walk around it and explore so that you get a much better idea of what it is. And you can actually edit it on the fly as you go. So you might notice this one needs a window, I might add a window there. This can use a window as well, I can use it there. And then once you've got something you like, for example, within 10-15 minutes, you can design this kind of apartment, you can 3D print it. So to give you an example, one of our users is Maze here. Once you 3D print it, it gets something like this.
Oh,
so
wow.
so very really easily 3D printed.
So what does it export as?
So it exports STL files.
Okay.
So if you have a 3D printer, we give you all the STL files for free. So if you don't have a 3D printer, we handle everything for you. The favor is you receive a 3D printed file installed. Otherwise, if you play Minecraft, it's a Minecraft box.
So are you a developer? Okay, I'm a developer. I'm creating a scanning product for the occipital structure sensor. Plus I'm coming up with a product I call Neoti VR, which allows you to use the sensor so that it knows your environment. Right. So maybe we should talk. What are you using, SceneKit on this? What's the engine that you're working with?
We're using a game engine to run it, so we're using Unity.
Okay, so you are using
and so all the geometry that you see in here is procedurally generated. So we're using a game engine. Okay. We're using the Unity game engine, so that gives us the gameplay. We're using allows us to use the gameplay. Okay. And all the geometry, we have a geometry engine, so the geometry is generated on the fly. What we like to do is we like to get some 3D cameras so that we can actually scan real environments, bring them into our software so that you can quickly scan a place and edit it in almost real time.
We'll talk to Occipital, the structure sensor.
Yes, I know structure, yes.
Yeah, they actually, most of their stuff is done in iOS, which I'm assuming that's what you have here is an iOS app?
Yeah, we have both an iOS that runs on the iPad, runs on the iPhone, and it also runs on the Mac as well.
Oh, okay. All right, so you're an Apple proof.
Apple, yeah. We also support Windows, so Windows 7, Windows 8, and we're currently working on Android as well.
Oh, wow, you've got a broad group then. Yeah. Well, they specifically have developed their sensor for the iOS platform. Right. And it's enhanced using, I think they're using Metal now as well. So it's both GPU utilizing the OpenGL functionality. Plus, you're familiar with the Prime Sense or the Connect. So it uses a newer version of the Prime Sense OpenMI in order to bring the stream in. Right. And it can capture rooms. And more importantly, like I said, we can reverse it so that you can be in that room. So let's say if you're in a standard bare room, it knows where your walls are. Right. And map them to the VR room. So I have a prototype headset that I'll be showing off tomorrow with them.
Oh, we're very excited to see that.
Yeah. So Lisa, talk more. I'll give you my card, give me yours. And then maybe I can have you on.
No, that sounds like a very good...
So I'll give you my podcast card, but this will also get to my own. So I run two companies, this one as well as Stoker Creative, which is now a 3D print design and scan. Yeah. And then I also obviously do some development.
Okay, yeah, we're very interested in the scan part because we want to be able to decorate. So we want to be able to easily scan things and get them into a format that we can use and bring into our system. Okay. So that you could actually decorate with stuff that's in the real world as well. So think...
for the brief, so if you've been viewing, you could have just skipped over that. Maybe I'll edit it out later on. So let's continue on our way. Bay Area retro group. Well, I don't know if we can see that here, but that is a So what do we have here? Okay. So you want to kind of talk a little bit about what you've got here?
How's it going?
Hi, how are you?
Good. What's up?
Well, you have now broken
What camera am I looking at?
whichever one. Actually, this is our streaming one, so if you want to see yourself live, you can go out to All Things 3D on Google+. But essentially, it looks like you're 3D printing pancakes.
Exactly. Well, this is the pancake bot. This is the pancake bot. The pancake bot is the world's first pancake printer. And essentially what it does is it allows you to take any design that you want, drop it on the computer, and you draw the pancake how you like it, press print, and then you get your pancake of your choice. So here we got a little rocket pancake from MakerFaire. And we're also working on little spiral pancakes that were generated with little alcohol that was written in Python. This is a way that kids can learn about technology and get inspired by making pancakes and learn about food and how food machines work. So that's Pancake Bot for you.
Cool. So what does something like this cost?
The retail price is $2.99, and it's going to come with a griddle, and it's going to come with an SD card with a library of images and text, along with a software you can download off the web. It's going to let you draw your favorite pancakes or your favorite characters.
So when can I get one?
In October or early November this year.
Okay, are you going to do a Kickstarter or you just...
We were on Kickstarter already.
Oh, really?
We raised $460,000. That was to help us with our manufacturing and licensing and everything like that, or certifications. And so now we're bringing it to market. So.
Great. How about giving me a card or something? I'd like to have you on our regular show.
You can reach us actually at pancakebot@gmail.com.
Pancakebot. Okay.
And then see how that goes.
Great. Well, thank you very much.
You're welcome.
So I'm putting everything to a new platform.
Hi. How about giving me an overview? Obviously, the important thing here is that it prints cool. There's no more burnt figures. Okay. So it's kind of like the Doodler except cold prints, right?
Yeah, what you have here is clear pop. It uses cooling, so there are no hot part, no melting plastic, and no bad smell. And you can do whatever you want with it. What's really cool about it is that we have inks with a variety of different properties. So what I can show you here is magnetic ink. If you hold out your hand in front of the camera, and if I bring this here, the magnet, boom, and I'm picking up all of the pieces because it's magnetic ink. What we have as well is aromatic ink. So they have different nice smells that we fuse into the paste.
Temperature sensitive ink. It will change color because of the temperature of my body.
Go ahead and take the microphone.
Yeah, squeeze it.
You have to keep the microphone somewhat close to your mouth.
I squeeze it for time and it will change color.
Oh,
So it's thermochromatic ink. Here we have glow in the dark, if we show it. So what we really want to do, CreoPop is really about innovation in materials as opposed to really printing. So we are working on a number of other inks, a conductive ink, body paint ink, elastic ink, and we really want to unleash users' creativity by enabling them to create whatever they want in a range of materials as well as colors, because we think for too long 3D printing has been stuck with just filaments of plastic, which is clearly limited. And you see the pen being used here, and since there are no hot parts, my colleague Ilya is just doing it straight on his thumb.
Yeah, I saw
so
that
you can do 3D nail art with this.
Oh, interesting. So what does something like this cost?
So you can order it on creopop.com, and you get a box which contains a pen and 3 cartridges. Each cartridge is enough for 14 meters of creation. So what's that, about 45 feet or something? So relatively long, $190 online, and the refills will be $19.99 for a set of 3 in various combinations.
You mean 1919?
119, so 119 for the starter pack, and then $20 for the refills, $19.99.
That sounds good. Very reasonable, and they're available now.
And they're shipping very soon. We're finalizing these units that you see here. They are mass-produced units. They are not samples. They are from the production line in China. We're finalizing now the surface coating on some of the plastic parts because our ongoing reliability testing showed some wear and tear effect based on the test protocol. So we don't want that to happen. So we're improving now the surface coating. Even though, I mean, I've never been able to scratch or do anything myself, but we want to have a really good product, and then we're going to ship them when we finalize that program.
Wow. Yeah, that's really neat. How about I take your card, and maybe I'd like to have you on our regular week show and talk about it a little bit. And I look forward to getting one of these.
Thank you very much.
Thank you.
Only challenge here in this noisy environment is to hear your questions. I was really trying.
Everybody is saying that. The problem is
so much background noise.
I can't speak too loud, otherwise I'll blast out my own mic. So. Oh well. Thank you very much.
Live?
You're live.
I'm not working with these guys.
Oh, okay. Are they coming back?
Yeah.
So actually, give it to them. I'd like to have them on my weekly show.
Are you going to get them on?
I will be, but I'm actually one of the speakers. But that won't be until the afternoon. This is my co-host card, but it goes in the same place.
Oh yeah, I got to talk to you about 3DI. Search engine. No, reach out to you later, man.
Okay, thanks.
Sorry about that.
That's all right. Appears to be the company that I did an interview with not too long ago. So, see if I can get in there. You remember me?
Sorry?
I'm from All Things 3D.
All Things 3D?
Yeah, so we did an interview with you guys not so long ago, guest crasher.
Sorry?
You guys were my guest crasher. The CEO of your company?
Yes.
Who's that?
I'm Mitch. I'm the CEO.
So did we talk together? Or did you have another interview?
When was this?
3 months ago?
3
It must have been Chris. It was probably Chris. Yeah,
he looks familiar.
You want to follow up with Chris? Yeah.
Or you? It doesn't matter.
Sure.
Okay, here you go.
Let's do it.
So at the time, we actually launched on Kickstarter, and we kind of went through your process and how it was really cool and how you'd be able to use it with multiple printers. So why don't you kind of tell us where you're at now with it, since it's been a few months?
Yeah, absolutely.
And I'll just kind of have that. So you can either get behind or out.
Sure. The wire one.
Maybe not. Maybe if I get in here. Excuse me.
We are still on Kickstarter also.
Go ahead and bring it up to you. Well, I remember this is the box, so I don't know who I talked to, but I had you on as a guest crasher. Now, did you just launch?
We launched about 3 weeks ago.
Are you from Canada? Yeah, I talked to you guys.
Yes?
Yeah.
It might have been fun.
You know what? We had
a team member, he had to leave for personal reasons, so it was probably him.
Okay, I think it probably was. But yeah, we went over your whole product and everything else. So you guys didn't even watch it, huh?
Sorry about the confusion.
Yeah, that's okay. Well, I'm glad I wasn't. I am a little older than you guys. I'm thinking, oh my God, it's going already. No, but hey, tell me a little bit more. It's been a few months now. Obviously, one of the things that I found intriguing about it is that you can pretty much take standard printers, 3D printers, and feed it with the proprietary system here that runs a multiple colored ink filament. So you can take it from there.
So we wanted to design a technology that solves...
Go ahead and bring it up.
We wanted to design a technology that solves a lot of problems that we're pioneering a single alpha technology. It's like the players are coming. So I'm not familiar with the recently, regular pictures are also related to now, the power with an object. So what we do is we take one of and we connect it together. So this gets back to a single then we'll compatible. So this power is out. This is taking important performance. It's combining it together to make single strand. So that's all done by the G code. Exactly. So there's something called tool shooting. They have tool chains. So what we do is we take that tool chain with patient and that does the color. This much yellow, this much green.
Yeah, and it obviously it's very slick. And some of the questions I had in the interview that I did with this other person was I noticed that it's somewhat discreet in its colors. Are you working on blending, or is it essentially one color at a time?
So our initial goal actually was to make a off-the-shelf printer. We make this realize that this is just this is really a way to model the way we design. So the first step was to introduce high quality multi-colors not to the tolerance. So we then came on board to speak with the colors. You can leverage some of these that's at blending, like in this case you can see these blending to the vertical effect on hardware. But a lot of the time what we end up doing is setting different expression material on the side so we can come back to the part yet even the high quality crisp colors. As you can see on the bottom side. Very cool.
Well, so how soon? I mean, obviously we launched on Kickstarter. When can we see this out? When can I buy one?
So we have launched on Kickstarter. We can buy it with 5 days left.
Okay.
Growth with the action and results of it. We're shipping our early bird units in December. And the next version will come early January, February 2016. So this is the campaign. Basically, what we're doing is to make a website and ship it out to Kickstarter.
And when will you be collecting pre-orders? When will the pre-orders be coming?
We're actually going to launch pre-orders on the site. That means after the events.
Okay.
But of course, we focus on fulfilling Kickstarter.
And that's the only right thing to do. Some people have not realized it, but glad to hear that. Okay, well, I'll be looking out for it. And the price, if you don't mind me asking.
Yeah, so it is $850.
Okay.
Depending on exchange rate, it's about $675.
Okay.
And that's, of course, a Kickstarter reduced price. To get back to back as much accessible as possible. So after the campaign, that's supposed to be the price like this.
Okay. Well, I'll have to keep that. So if I pre-order during that time frame, I can get it for whatever the Canadian rate is. The pre-order, the initial pricing is how much again?
So the pre-order on Kickstarter is $49.
Okay.
I get you my cards that so I'm Mitch.
So you're the CEO then?
I'm the CEO, yes. You must have spoken to Sarma, he's our marketing director.
Probably.
Yeah.
And I'll give you my card, or my co-host. And
amazing, okay. Thanks, Chris.
no, I'm actually that's my co-host.
Okay.
We do it together, and that's all I've got left. So, but the email address goes to me.
Okay, perfect.
So yeah, follow up, and then we'll get you back on, and see how this is going. But, yeah, it's a very interesting product.
Thank you very much.
Thank you.
Nice to meet you.
I'm not exhibiting here, but I'm doing affordable version of laser sintering machine.
Really?
Yeah. So we have like this kind of print.
So do you have a booth, or you just?
No, we don't have booth.
Okay.
Yeah, but the thing is that we are like.
Here, go ahead and hold that close to your mouth.
Okay.
So you're doing laser sintering.
Yes, so we do the laser sintering, quite affordable version of laser sintering. So we have some, for example, we have printed a couch, so you cannot print it on a regular FDM because we have foods on the back. Okay. We are able to make working mechanisms, so like we can have a chain, we can have like working mechanisms here. So this one was done in one single print, and we are able to print around 100 of these kind of keychains at once. So you don't need a lot of labor work afterwards. And also we are able to 3D print a book. So we are able to do even this kind of stuff.
So what is the name of the company again?
Sinter It.
Sinter It. Actually, I covered you about a couple weeks ago on that show.
Okay. So
yeah, no, we're excited about it.
Okay.
Huh?
In Berlin? So no.
We're all things 3D.
Okay, so you covered us on.
Yeah, I saw it. I normally cover the news on Fridays.
Okay.
So I saw it there, and I actually sent you guys a contact to get you back on the show. So give me a business card, and I'd like to do an interview with so we can talk about it more.
Okay, I will just give you the business card.
So actually, the quality looks pretty good.
Yeah.
Obviously, you have those same. I said, those look familiar. If you have those up on either on your website.
Yeah, we put that online, but some of that. But the thing is that like try to touch it and feel it because it's quite different story when you that.
And there's my card.
Okay, thank you.
It's pretty neat.
Yeah, so we are really unique comparing to others.
So my question that I posed, since I didn't get a chance, was SOS printing, for the most part, most of the patents are expired. So is that one of the reasons that you're moving in that direction?
So we are not scoping what's not patented, what was patented, but we invented our own way of 3D printing. So we are basing on laser sintering, but it's like we are basing on laser.
Go ahead and stay there. Okay. You keep moving closer, and no, that's good. Okay. Yeah, sorry. So you're basing it on laser, but what makes it different?
So the thing is that we not just copied what's in patents that's expired, but we invented new things, and that's why we are able to make it affordable and with really good quality. And do for example this book because we didn't find anyone up till now to copy that, so we are waiting.
So on that note, did you have a price when it was announced, or?
So we are not yet sure about exact pricing. We plan to go for pre-orders for around 5,000, and later on the resale, price from resellers will be like around 7,500. But still, it's not solid price yet.
Wow, well, that's really nice, and yeah, I think that's what caught my attention. So, like I said. I'll follow up on this. We'll get you on the show either as an interview of 20 or 30 minutes or have you as a guest crashers on Friday to talk more about it. We're kind of excited about it. My co-host and I do a lot of 3D printing. We follow a lot of different things, and we have a unique printer out there. So,
Thank you very much.
So where are you from?
We are from Poland, from Krakow.
Okay. There's a couple of, that's what I made the point on, there's a couple of people from Poland that are doing some really great 3D printing.
Yeah.
So you flew all the way out here, huh?
Yeah. So we came here, we also U.S. On collision conference.
Okay.
So we like going around the U.S. and heading back to Poland tomorrow to work hard and hard to make this possible.
Well, I look forward to it. Again, I'll email you and get you on. We'll use Google Hangouts on air. We'll
Okay.
live cast points.
Okay.
And then everybody in the world will be able to see.
Thank you.
So thank you.
Thank you.
That's about as far as you can go. Limited to how much I can do.
Okay.
Yeah.
Still.
Are you at university?
No, I'm not. I work in solar.
Okay. No, that's good.
Hi. You want to give me kind of a brief rundown of what we have?
Yes, we'll give you a brief rundown.
I'm having a card. You have a card?
I don't, but I took yours.
Okay. I'll give you the card. Keep it as close as possible to your mouth. So essentially this seems structured 3D. Can you kind of tell us
So just get a quick picture of what we're doing?
Yes, please.
Cool.
Go ahead. Yeah, we're live, by the way.
Oh, awesome. I'm Andrew Finkel, the CTO at Structured Printing. We do 3D printing of paste. So things that cannot be made into filaments now are able to be built into a 3D shape on a 3D printer. So what we do is we make an extruder that is universal. It works with a lot of different 3D printers, such as the BioBot, Ultimaker, a lot of the different people here in the tent tonight. And the idea is to complement the plastic filament printing. So right now we're printing silicone RTP, high temperature, and we're making our own customized gaskets. And this morning we were printing with Nutella, so we can do everything in between. And it's been designed so it's food safe, everything is medical grade, so you can go from silicone to Nutella and not afraid of anything.
Oh, really nice. So what is it? $349?
Nutella gasket, what is it?
$349?
Yeah, so we're selling our Discovery Unit this weekend for $350. It's on sale. It's available on our website, structured.io. That's structured with 3 instead of an E.
Okay, because there's another company called Occipital that I developed for, called Structure.io.
Yes, yeah, they're doing the 3D scanner, right?
Yep.
Yes. We were talking to them yesterday when we were about doing a commercial. Hi, we're Structured. We're Structured.
That sounds kind of fun. Yeah, I actually do a lot of work with them. I design some accessibility products. But yeah, this is pretty cool. So what I'd like to do, I don't know if you gave me a card already.
Yeah, I'll give you my card.
I'd like to have you back on either as my guest crasher or maybe a little interview to kind of talk about the whole process.
Yeah, I love that.
So I'll follow up in the next week. It's pretty cool. So this is available now? Is this available now? Or
it's available for order on our website right now. Our lead time is about 8 weeks. We're just finishing up the final shipments for our Kickstarter that we ran last summer, and we're hoping to be able to start being able to meet the orders in shorter demand later this summer.
I know how that is. Okay, well great. Really appreciate your time and look forward to talking to you more.
Nice to meet you.
Nice meeting you.
Yeah, we did the cheese whiz.
Thank you.
I'll have to step outside.